This week on the show, we have a 36-year-old UFS bug that's been fixed for you, a BSD for the road, automatic upgrades with OpenBSD, DTrace, ext2 support in FreeBSD, dedicated SSH tunnel user instructions, as well as upgrading VMM VMs to OpenBSD 6.5 in this week's episode of BSD Now. BSD Now, episode 298, BSD On The Road, recorded for the 15th of May 2019. Hello, I'm your host, Benedikt Reuschling.
And I'm Alan Jude.
And this is a popular Twitter goat. Ignore him. Headlines for this week start with a 36 and older year-old bug in fast file system UFS has been discovered and patched. Yes. So you can see how old this file system is.
Yeah, well, and how old the bug is such that it's older than either of us, right?
Oh, yeah, for sure.
Yeah. This update eliminates a kernel stack disclosure bug in UFS and FFS in the way directory entries are stored that is caused by uninitialized directory entry padding being written to disk. So basically, with the way UFS works, everything is written out in 4-byte increments. That's the smallest size you can do. And so the data structure for a directory is 32 bits. But the name of a directory entry might not actually be a multiple of 4 bytes long, right? If you have a 5-byte directory name, then it will actually be 5 bytes plus, I think, the null bytes. So there'll be 2 bytes left over. And because those bytes weren't overwritten or weren't initialized, they might contain data with what was in that location in memory before. And that could result in, could possibly result in data that might be sensitive from the kernel stack being written out to the disk, where somebody might be able to read it. So I'd say it can be viewed by any user with read access to the directory where the directory entry was created. Up to 3 bytes of kernel stack are disclosed per file entry, depending on the amount of padding the kernel needs to pad out that directory entry to be 32 bits long. The offset in the kernel stack that is disclosed is a function of the how long the file name is. Furthermore, if the user can create files in a directory, this 3-byte window can be expanded 3 bytes at a time for up to a 254-byte window, with 75% of the data in that window being exposed, whereas the rest of it would be overwritten with parts of file names. The additional exposure is done by removing the entry, creating a new entry with a 4-byte longer name, and then extracting 3 more bytes by reading that directory and repeating until 252-byte name is created, because that's the longest one you can do. So this exploit works in part because the area of the kernel stack that is being disclosed is in an area that typically doesn't change that often, perhaps a few times a second on a lightly loaded system. And these file creates and unlinks themselves don't overwrite the area of kernel stack that's being disclosed. And so it's not constantly changing, so you can actually have a chance to extract a string of data. Anyway, it goes on. It appears this bug originated with the creation of the fast file system in 4.1b BSD, which came out circa 1982, or more than 36 years ago. And because of that, the same bug is likely present in every Unix or Unix-like system that uses UFS or FFS. But amazingly, over all the years, nobody has noticed until now.
Whoops.
So in addition to the patch that zeroes out those extra bytes so that the data doesn't leak out to the disk, they've also updated the FSCK command to have a -z flag, which will go through and overwrite that padding with zeros on your disk so that any data that has leaked out can be overwritten. It only needs to run once on each file system, once you have a patched kernel, you'll never leak any more data. So when you run the fsck-z to zero out any data that leaked out previously, you'll then not have any more problems.
Okay, and OpenBSD has reacted to this?
Just wanted to say that the patch was submitted by David G. Lawrence, which
Right.
I assume means he's the person that found it. And yeah, once you have a patched kernel, just run the fsck-z and your system is all sorted out.
Okay, so that's UFS only, not ZFS or any other file system as we know.
Yes, and then because all the BSDs use some version of UFS, I think on OpenBSD it's actually an older version of UFS, V1, but their impact was a bit different because of the mitigations that OpenBSD uses, and some of them are maybe not even on purpose in this case. So Theo has the commit message for their side of the fix, and it says 3 bytes of kernel stack address space were leaked into the on-disk directory format with some gritty work up to 254 bytes could be disclosed, and then links to the FreeBSD commit. And then goes on to say, the impact on OpenBSD is actually quite limited. I'm going to do these out of order because that makes more sense that way. But reason number 2 is they changed the read syscall when you call read on a file descriptor that's actually a directory. It doesn't work. Back in July of 1997, Theo changed the read syscall in OpenBSD so that if you called it on a directory, it would return end of file. That basically read 0 bytes and there was no data. So when you try to call read on a directory entry in OpenBSD since 97, it would actually just return as if it was an empty file. And he did this because he didn't like when he did grep star and it would display garbage and mess up his TTY because of the binary data in a directory entry. And then trying to apply viz, VIS, to display it nicer, only for directory entries seemed silly. So he changed read to just return end of file when you try to read a directory entry. So that mitigation. And then later in September of 2016, they changed it to actually return an error, is directory. And that way, you know that you couldn't read it because it's a directory rather than that you tried to read it and got back 0 bytes because the file's empty. Anyway, so that mitigation, which wasn't done for security reasons, but just because Theo didn't like grep corrupting his terminal, means that a regular user can't use read on a directory file descriptor and be able to see this disclosed data that might have been written to disk. And then number 1 is that the stack bytes can be found in raw device reads. So you'd have to be in the operator group to be able to read from the disk, like the disk device directly, rather than via the file system. So because you can't read from the raw disk as a regular user, and because the read syscall stops you from reading it via the file system, only people in the operator group would be able to read the sensitive data that might have been written to disk. And at this point, if you can read the raw disk, you can probably do more powerful attacks than reading a little bit of kernel memory. Because you're in the operator group, which lets you do all kinds of things. And then a third one is number 3. In 2013, when Gunther adapted the get dents, or get directory entries, directory reading system call to be 64-bit, the userland data format changed to be 8-byte aligned, making it incompatible with the 4-byte aligned UFS on disk format. As a result of code refactoring, the bad bytes were not actually copied out to userland. So as part of the changes they did for INO64, they changed it so that it wouldn't copy out those excess bytes and cause this leak that was just found and fixed in FreeBSD. So the bad bytes, if you were using UFS before 2013, there might still be data on your disk. and they'll remain in old directories on old file systems, but nothing makes those bytes user visible. There will be, and so since 2013, OpenBSD hasn't actually leaked data this way because of this other change. And because of that, they're not going to issue an errata patch or a sys patch.
Yeah.
But he does say that he urges other systems which expose this information to userland to actually issue an errata, since 254-byte information leak of the kernel stack, which is could be useful for doing ROP chain building to then attack some other bug to get access or something.
Mm-hmm. Yeah.
He says, especially if you don't have the link order randomization thing like OpenBSD does, where it relinks the kernel in a different order every time you boot.
Okay. So I guess the other BSDs or users of UFS in some variation will have to look into the issue and see if that's relevant to them.
Yeah. You might want to, if other people have regular user access to your system where they might be able to use read on a directory entry, then you might want to apply this patch and run the fsck-z to zero it out.
Mm-hmm.
Although it's slightly interesting, it's more I think an interactive attack is more useful there, because what was in the kernel stack like 5 years ago when I created that directory, probably not as useful as being able to create new files in your home directory right now and be able to read from the kernel stack.
Mm-hmm. Yeah. So an old file system still maintained, still has bugs. So that's always interesting. And I mean, UFS alone has an interesting story.
Couldn't cause data loss.
No.
Actually keeping more data than you wanted it to.
Yeah, if you look at it that way, yeah. All right. Next up in our list of headlines is NomadBSD, a BSD for the road, over at itsfoss.com. And they have a little bit of a coverage for NomadBSD. And they write, as a regular Foss readers should know, I like diving into the world of BSDs. Recently, I came across an interesting BSD that is designed to live on a thumb drive. Let's take a look at NomadBSD. NomadBSD is a different breed than most available BSDs. NomadBSD is a live system based on FreeBSD. It comes with automatic hardware detection and an initial config tool. NomadBSD is designed to be used as a desktop system that works out of the box, but can also be used for data recovery or educational purposes, or to test FreeBSD's hardware compatibility.
Yeah, it was funny there. I remember when I was teaching, a student had, I think it was a SD card or something, that was slightly corrupt or something, and they wanted to try to get their files back off of it. And there wasn't really an easy way to do this under Windows. But booted a USB or a FreeBSD live file system off of USB on their computer, used DD to get a full image of it and be able to mount it as a memory disk and extract the files that they wanted and get stuff back. So yes, I use FreeBSD as a rescue system like all the time. So having one that's more designed for that and gives you the GUI out of the box and so on is quite useful. Yeah.
And so this is a German BSD, which comes with an OpenBox-based desktop with the Planck application dock. And NomadBSD makes use of the DSB project, where DSB stands for Desktop Suite for FreeBSD. So D, desktop, as suite.
Suite doesn't have an E.
Right, suite, yeah, okay. And that consists of a collection of programs designed to create a simple and working environment without needing a ton of dependencies to use one tool. So DSB is created by Marcel Kaiser, one of the lead devs of NomadBSD. So there's the connection. And just like the original BSD projects, you can contact the NomadBSD developers via a mailing list. And they had recently their version 1.2 being released. So there's also a little screenshot there.
Yep, they have a list of the applications that it includes, including a file manager, a CD ripper, the FileZilla SFTP client, Firefox, Fish command line shell, GIMP, a PDF viewer, Git, HexChat, a text editor, Midnight Commander, Pale Moon web browser, another file manager, Pigeon, the instant messaging client, a BitTorrent client, Redshift, because you don't want to be losing sleep because you were debugging into the night. Some terminal emulators, Thunderbird for email, VLC for media player, ZSH because everybody needs a shell that's good, and the Plank application dock.
Mm-hmm. And so as news in their 1.2 version, they say that, so this was released on April 21st, and this means that NomadBSD is now based on FreeBSD 12.0 patch level 3. Trim is now enabled by default. One of the biggest changes is that the initial command line setup was replaced with a Qt graphical interface. And they also adapted a Qt5 tool to install NomadBSD on your hard drive if you so desire. So it's not just USB only. A number of fixes were included to improve graphics support, and they also added support for creating 32-bit images.
Useful if you have older devices.
Oh, yeah. And that makes the distribution even more compelling to more users who actually want to run it, not just on a USB stick. And so they write that they first discovered NomadBSD back in January when they released 1.2 RC1. At the time, they had been unable to install Project Trident on their laptops. They were very frustrated with BSDs back then, apparently. And then downloaded NomadBSD and tried it out. And it initially ran into issues reaching the desktop, but RC2 fixed that. And then they were unable to get onto the internet, even though it had an Ethernet cable plugged in. And luckily, they found the Wi-Fi manager in the menu, and they were able to connect to the Wi-Fi. Okay. So overall, their experiences with NomadBSD were pleasant, they write. Once they figured out a few things, it was good to go. And they hope that NomadBSD is the first of a new generation of BSDs that focus on mobility and ease of use. BSD has conquered the server world. It's about time they figured out how to be more user-friendly.
Interestingly, looking at the breakdown of the little unofficial poll they have going on there, 36% of people have used BSD, 26% of people have not, but plan to someday, and then 38% are using Linux.
Well, yeah, that's a good statistic to see.
Mm-hmm.
So, time for the news roundup this week. We have OpenBSD automatic upgrades. Remember that we talked about OpenBSD 6.5 came out recently. Mm-hmm. So this is the tutorial for the people who haven't upgraded yet. So OpenBSD 6.5 advertises for an installer improvement. RD-set-root, a build time tool, is now available for general use. And it's used in combination with auto-install. And it's now really easy to do automatic upgrades on your OpenBSD instances. So that's good to hear. And so they first manually upgraded their OpenBSD sandbox to 6.5, just in case. Once that was done, they could use the stock RD-set-root tool. And the plan there is quite simple. You write an unattended installation response file, insert into a bsd.rd 6.5 installation image, and reboot their other OpenBSD instances using that image. So that's fairly common nowadays that installers bring their little files that make the installation automatic and don't let you answer the prompts. So that's automatically done. So that's the preparing the RAM disk image, in case you don't know how to do that. There's 3 commands.
So they use RD-set-root to make a new file system out of the existing RAM disk. Then they create a memory disk of that and mount it to /mnt.
Yep.
And then they fill out the auto_upgrade.conf file with the questions and answers.
Yep. Location and some other things that are important. And then you save those changes, of course, and apply those modifications. And yeah, then you upgrade automatically by just running or by scping that bsd.rd to a remote machine, and then SSH to that machine and execute that. And reboot. All right. So there's some extra notes there. There must be a way to run one-time commands in the manner of fw update to automatically run sysmerge and package upgrades. As for now, they'd rather do it manually. So they do the sysmerge, then the package_add, and the package deletes for the old packages that are not a part of the distribution anymore or are outdated. So this worked like a charm, they write, on two Synology KVM instance using a single SD0 disk, and on their ThinkPad X260 using encrypted root with key disk, and on a Vultr instance using encrypted root with a passphrase. And oh, by the way, the upgrade on the X260 used the IWN wireless connection.
Yeah, so it even worked over wireless.
Mm-hmm. Oh, wow. And they just got that Florian at OpenBSD has released the sys upgrade utility, which should be released with OpenBSD 6.6, and that will make upgrades even easier. Until then, happy upgrading.
Yeah. So then we have a story about DTrace support for the new ext2 FS work in FreeBSD.
So we can now see inside that old file system.
Yeah, so basically they replaced a bunch of printfs that were behind the debug macro for things like block allocation and on-disk structure verification errors and so on that normally only printed a message if you had debug set at compile time, or ones that would just return an IO error and never actually log anything. All of those have been extended so that they actually are DTrace probes, so you can enable the debugging at runtime without having to recompile.
Ah, excellent.
They did leave some of the ext2 fs_print_extents debug macro, saying it is impossible to replace it with a DTrace probe because of the extra logic required to walk through file system extents. So there's still a couple things that are very specific that are compile time, but most of the useful stuff is now all detraceable.
Oh, excellent. In case you're still running that file system or compatibility into that.
It's mostly you're using the ext3 and 4 support is all based on this code, so it's inherited by all of them. And then they said that some errors obviously are still printfs unconditionally, so even without debug flag. So, if there are file system feature incompatibilities or problems with the checksum on the super block, those print out errors like they always have. But basically all the debug stuff that was hidden behind a compile time flag and then might be a printf are all DTrace probes now.
Mm-hmm. Yeah, this could be used for debugging or even teaching, like this is how a file system works, basically, and you fire up some probes and see what it's doing when it's writing data or reading from the disk or from the file system. That would be nice.
It shows how they replaced some printfs with some probes here, or, when they had an error, instead of just returning the error, they would actually print a probe saying it couldn't allocate a metadata block or whatever. Or here's the common example. So if the debug flag is set, then printf this and then do something. And then now that is a DTrace probe, which does nothing if DTrace isn't running, but does give you the message if DTrace is running. Meaning that you can enable this at runtime instead of having to recompile the whole UFS kernel module just to get the debug messages. Yeah,
this is a good explanation of how you can detracify, if that's a word, some code.
Exactly. Basically why you shouldn't have if-def debugs anymore. You should just have DTrace probes.
Yep. Okay. We also have a story about how to create a dedicated user for SSH tunneling only and why it's important. So they start with that they use SSH tunneling a lot for everything, pretty much everything that they're doing on dataswamp.org. And it looks like yesterday they removed the public access to their IMAP servers. It's now only available through SSH tunneling to access the daemon listening on localhost. They have plenty of daemons listening only on localhost that only they can reach through an SSH tunnel. And if you have plenty of daemons listening on that, you don't want to bother with SSH and redirect ports as you need. You can also make a VPN using SSH, OpenVPN, and so on between your system and your server. They tend to avoid setting up VPN on the current use cases as it requires more work and more maintenance than running SSH server and an SSH client.
Well, and the big thing can be sometimes the computer you're using isn't yours. And so it can be difficult to install a VPN client. Whereas, an SSH client is usually already there. And if not, is something very portable or something that you can download and use without having to have administrative privileges on the machine or something like that.
Yeah, even on Windows, you just download PuTTY or it's already there then. Or use the shell even that's nowadays on the newer Windows versions. But we digress. The last change for their IMAP server added an issue. They want their phone to access the IMAP server, but don't want to connect to the main account from their phone for security reasons. So they need a dedicated user that will only be allowed to forward ports. And this is done very easily on OpenBSD. The steps are first to generate the SSH keys for the new user, then second, add a user with no password, and then third, let's see, like this, allow public key for port forwarding. Obviously, you must allow users, or only this one, to make port forwarding in your SSHD config. And that's what they show here, how to do the entry.
So they basically make an authorized key file that says that this user is only allowed to run this one command.
Yeah, so that in case you forget,
or rather,
you get the message.
When you log in with that SSH key, it will run that command and only that command, I think.
Yeah, and then immediately log you out.
I don't think it logged you out because that would break the tunnel.
Right. Yeah. It's in the authorized keys, just to name the key and give it a little bit of more description. So then you establish your tunnel. That's also a little bit where a lot of people are struggling with how to create tunnels with SSH. So which is the local side, which is the remote side, and which port do I have to put where?
The man page lists them. I have to look it up every time, but
yeah. But if you do this regularly, then it's probably in your shell history.
Because I was doing a slightly funky one. I was using it to access the IPMI on a server. So the SSH was running on the NAS at my house. But I had to make it listen on the LAN IP address so that my Windows computer could connect to my NAS, which would then SSH tunnel to a server at the other side, which would then actually forward it to the IPMI of a different machine at that side. So there were 4 different computers involved. Yes.
But it all worked. It's a nice thing. And you can just tunnel and connect from pretty much anywhere. So, and
talk a bit about the auto SSH tool, which you can get from ports.
Oh, yeah. So they have a command that starts the auto SSH tool and restart that if forwarding doesn't work, which is likely to happen when you lose connectivity. Take some time for the remote server to disable the forwarding effectively. And then, it will keep a live check so the tunnel stays up and ensures stop. And they have some more instructions how to make the tunnel work on Android phones or Android devices. Basically, just you upload the private key to your phone, add it to ConnectBot from the main menu, create a new connection to the user and your remote host, choose to use the public key authentication, and choose the registered key. Then you uncheck Start a Shell session, which is the equivalent to the -N SSH flag, and then from the main menu, long touch the connection and edit the forwarded ports.
Yep, and they also mentioned that because you're a regular user, you can't use ports less than 1024 unless you're using something like the Mac framework on FreeBSD. So they just did port 9993 instead of 993. So that they would be able to listen on that port to connect to IMAP.
Okay, that seems pretty straightforward. So no more excuses not using tunnels.
And lastly, we have a story here from OpenBSD.Amsterdam about upgrading VMs. So they said now that OpenBSD 6.5 is out, there are 2 easy ways to upgrade your EM. You can either do a manual upgrade or leverage the auto install system. So on the host here, they're using vmctl console on the machine, and then stopping it and starting it. So once they console in, they grab the new RAM disk for 6.5, check the signature with Signify, and then install it. Then they also grab, and they show how it's different if you want to grab a snapshot of current instead of 6.5. Once you're done, reboot. You'll be prompted if you want to do an upgrade or an auto install. You can select upgrade, and it will go through. If you select auto install, you'll also want to look for upgrade.conf and provide it with what sets you want to use and so on. And then you get an upgraded system.
Very nice. Seems like OpenBSD did a lot of work in that area. Upgrading.
So I guess this is just a slightly less automated version of the one we covered earlier.
Yeah.
Just doing multiple VMs from the host instead of doing it individually on each machine.
Yeah. So one is the host, one is the virtual machines. Yeah.
Yeah. But yeah, this is all done via the vmctl console command, which is interesting.
So it's time for the Beastie Bits this week. We have a story from Ted Unangst about PowerPC 64 architecture support in FreeBSD ports.
Well, this is, I think, from his RSS aggregator thing. But it's basically his comments on one of the papers from AJBSDCon, actually.
Yes.
Paper number 2A from AJBSDCon contains an excerpt where it says, for my project, I built the entire ports tree for PowerPC 64 using Poudre and basically went through and fixing all the compilation errors as they happened. So in this paper, they specify the challenges they met during porting software to make it work on the power processors on FreeBSD and how most of the problems can actually be solved. And so Ted's comment was, this is pretty trivial stuff if only people actually cared. And it's relevant beyond the narrow scope of just FreeBSD and PowerPC, but just how, ports in general, how most software could be made to work on BSDs and different architectures with just tiny tweaks. And there's oftentimes it's the same tweaks for each different bit of software. And if people would just do that the first time, then more software would be more portable.
Okay, well, on that front, he may have something there, but still the effort
is. Follow the link. You can follow the link there to get the whole paper from AJBSDCon.
Yes, yeah. For people who missed the conference, they can find the papers. Okay, next up we have GhostBSD 19.04 overview. This is a tweet and
about a YouTube
simple
video, basically.
A simple, elegant desktop BSD operating system. So there's the YouTube video where they basically do a rundown and a little bit of walkthrough to show what the system can do.
Yep.
And here's something from HardenedBSD. They will have 2 user selectable ASLR implementations.
Yeah, so you'll be able to select from the HardenedBSD one and the regular FreeBSD one. Basically, they had to merge the FreeBSD one to avoid having a diff with FreeBSD that was going to cause a merge conflict every time they tried to pull in newer stuff from FreeBSD. So they had to reconcile stuff so that you can switch between the two rather than just not having the FreeBSD one because it caused too big of a delta.
Yeah, over time, this would diverge too much. Yeah.
Mm-hmm. Then our friend Patrick, who runs BSD TV and does the live streaming for Nicebug, and is going to be the driving force behind it at BSDCan this year and last year, has found a little bit of spare time in between a couch cushion or something, and managed to post a talk from February 2016 Nicebug meeting about interesting things you could do with the shell. So Shell Foo by Ike Levy, who we interviewed a couple of years ago at AJBSDCon. But it's, video, jump to the next one. It's about an hour and 20 minutes of cool things you can do with the shell and things you should watch out for when you're using the shell for scripting.
So even seasoned Unix users could learn something from that?
Yeah, how to avoid race conditions when updating files and all kinds of interesting stuff are in there.
Okay. Something to bookmark. Okay, and the last question or the last item that we have here is, what is ZIL anyway?
So, don't, like me, assume this is a cool article about a deep implementation detail in ZFS. This is not actually.
Oh.
So this is related to another thing we were interested in, which was archive.org managed to get a dump of the a random point-in-time backup from Infocom, the company that made a bunch of interesting games, including Zork. So it turns out those games are written in a language called ZIL. And so the Infocom ZIL code dump has kicked off a small whirlwind of news articles and blogs posts. A lot of them are somewhat hazy on what exactly this ZIL is and how it relates to MDL, Lisp, Z-code, Inform, and the rest of the Golden Age interpreted languages.
Yeah, here's some code excerpt in case people are interested in how that looks.
So they say the first version of Zork, which was a text adventure game, was MDL Zork, and that was what Tim Ederson, Mark Blank, Bruce Daniels, and Dave Lebling wrote as MIT hackers back in 1977 through 1979. MDL was the MIT design language, which was a Lisp-like functional language created at MIT. And MDL ran on the PDB-10, which is where this version of Zork was run. Then, Zork was ported to Fortran by Bob Supnick in 1980, and then to C. These versions, generally known as mainframe Zork or Dungeon, circulated among the DEC users and wasted years of mainframe user time. And along with mainframe Colossal Cave, changed the lives of many people, including the author, who was 9 at the time. At the same time, those MIT hackers joined a company and set out, well, to make business software. If you look at their early plans, but they figured they'd first make a quick buck by porting Zork to home computers. Therefore, the MDL programs couldn't possibly run on an Apple II or a TRS-80, so the Infocom folks sat down and designed the Z machine. Not going to go through the whole story in depth, but if you're interested, they have some links for stuff over at the Digital Antiquarian, if you want to know about history there. But basically, Infocom would write a game in the Zork implementation language, a high-level language derived from MDL. Then a compiler called Zilch would then turn that into basically machine code for the various machines. Into the binary format. That binary format, called Z-code, was a program for an imaginary computer called the Z machine, which today we would have called a virtual machine, as in like the Java virtual machine rather than as in a VM where you run Windows or something. Anyway, nobody intended to build a Z machine, but they could write a program that any machine could then emulate a Z machine. This program, called Zip, was compact enough to run on a 16-bit home computer. So Infocom could distribute the Zip runtime and the Z code file on a floppy disk or cassette tape and have a playable game that was written in ZIL that was compiled with Zilch into Z code, and then that Z code could be run by the Z interpreter on the computer. So ZIL is not a mystery. We haven't had a lot of ZIL code available before this week, but someone scanned an Infocom ZIL manual a number of years ago, and you can read the manual over here, which was dated in 1989. Although one interesting thing is that the ZIL language and the Z machine and so on evolved as they wrote newer versions of the game. So documentation from one era and code from another era may not actually quite match up.
Yeah, it's been very much alive back then.
And then they have a little excerpt from the combat implementation, which define villain strength as villain and O strength of dot villain. Yeah, it's not exactly readable.
But I guess language historians are interested in seeing how that language evolved or actually was originally written. Okay, So it's time for feedback and questions, right?
In here, they're comparing the MDL version of the code to the ZIL version of the code. And you see how the languages differ slightly, mostly in keywords by the look of it. And yes, if you want to know more, there's lots more detail in the code or in the article.
All right. So time for feedback and questions. As always, we ask you to send us feedback and questions so that this section won't be empty. Send everything that you have, questions, comments, show notes, ideas to feedback@bsdnow.tv, like Quentin did for our first question here. He tried to schedule an interview, basically. Writes, Dear BSD Now team, I've contacted you following a discussion between my colleague Rigoletto and Alan Jude on IRC. They discussed the possibility of an interview on ADA for BSD and indicated that we should connect with you for the organization of the interview. We'll be the one responsible on our end. Thanks a lot for the opportunity and let me know what needs to be done to move forwards. So this might be a future interview that we have.
So I'm kind of interested in how many people that watch BSD Now would be interested in learning about ADA. Because I'm not sure how many people are. And so... Yeah,
maybe
let us
we
know
can
if
start
you'd be interested in seeing this, and then if there's enough interest, we'll make it happen.
Yeah, maybe we start some kind of poll on Twitter or something on the BSD Now Twitter account, and yeah, we'll see how interested people are about that. So it's ADA. It's not just ADA. It's ADA on BSD or with BSDs. Right. Okay. So thanks for that question or for that approach. Next up is DJ with an update to, I guess, a question asked earlier. Here goes. Alan, Benedict, and BSD Now crew. I finally have an update from last Halloween episode 269. Zombie ZFS question. Success. Following Alan's precise guidance and sage advice, combined with hardware voodoo, I managed to Easter Sunday to resurrect my zombie ZFS pool. Like pure coincidence. Apologies in advance if the debrief is lengthy. This may be an interesting deep dive into how the solution worked. So confirming Alan's point, when ZFS processes hang waiting for a missing, removed, or unavailable provider to respond, the only way to kill them was by hard shutdown or power cycle. More commands that hang were the zpool status commands, zpool clear, various zpool imports.
In particular, they said zpool status was fine, but zpool status -v, where it's going to enumerate the files that are damaged, was hanging. And then yes, zpool clear -nf, so zpool clear by itself resets the counters of errors. You know, when zpool status you have read, write, and checksum errors.
Yeah,
it resets all those to 0, and it also I think restarts a scrub over at the beginning and can reopen devices. For example, one of my servers is the server and then external SAS to a shelf with more disks in it. Well, one time the power to that shelf went out because of a problem with the UPS it was on, but it didn't affect the server. So I had a pool made up of a bunch of RAID Zs, and 3 of the 5 RAID Zs went offline. Obviously, that faults the pool, but the server was still running. So once the shelf was back online and the pool was up, I just ran zpool clear. It re-attempted to open all those devices. They opened, it resilvered a little bit, and then started to scrub, and everything was fine.
Cool.
So that's what zpool clear does. Now, if you're in the case where you have a faulted pool, for example, Koobs had this on IRC earlier this week, or not on IRC, on Twitter, he described it. He had a power failure or something, and it corrupted his pool metadata. And so the pool would import, but then stop immediately because it was faulted, because there was corruption of the metadata. And so when he tried to run zpool clear -n capital F, which is supposed to attempt to roll back to an earlier Uber block that isn't damaged, but the -n flag says, just try it, don't actually do it, so that you know if it'll succeed before you try. Because once you try it, you can't ever go forward again, right? Once you roll back, everything forward is gone. But he was getting an out-of-memory error when trying to do -n capital F, which is still something I need to look into. Anyway, this user was noting that when they ran zpool clear -nf, it was hanging even when they were doing the no-op flag, which isn't actually supposed to do anything. The problem is it tries to read, and when there's a problem, it can't make progress.
Okay.
They did find that we're able to zpool export just fine, but when they tried to import, they would have problems.
Okay.
And they also tried to do an import read-only, but found that it hung as well.
Yeah.
So he said after all that failed, he tried reconnecting the disk drives in the mirrored pair, started getting errors, lots of no peripheral AHCI channel 0 errors. Or the rescan was already queued and so on. Sometimes hanging the system entirely. Doing some web searches, I found some bug tracker posts from Chris Moore and people in FreeNAS, basically identifying this as a problem with the cable or connectors, and that's not necessarily something you can work around with software. I just had to open the case and keep plugging away at different permutations of where to connect the drives and using different cables, how to position the drive and the cable, and various other magic dances. And eventually, I stumbled across a configuration that made the errors go away, as it happens on one side of the pair connected to the main board and the other side to an HBA. In retrospect, all the errors may likely have been caused in the first place by this hardware jostling loose and becoming evil. Alright, so now the disks show up in the system and it doesn't crash. It's just zpool online and the disk comes up and they resilver. But then he says not so fast. Although ZFS could see the previously removed drive with the correct ID, I could not bring it online right away. The rearranging of the cables changed the device names, but ZFS won't care. That won't be the problem.
Yeah.
Anyway, he says, my attempt to online the drive by its ID resulted in a message that the device was online but in a faulted state. That's generally bad news. And now considering detach rather than online, but I rebooted first, and then everything suddenly worked. Automatically came online, started resilvering, and corrected all the errors. If I had been unable to reconnect the missing device, I would have been tempted to detach that missing device and then reattach the device and basically resilver it. Although, if there were any checksum errors on the other side of the mirror, that would have made those permanent. So they say, out of curiosity, if I had detached, then somehow later reattached the missing device, would it again have worked as a mirror and successfully resilvered? Yes, it would. But again, if there was a checksum error on the remaining side of the mirror, it wouldn't be able to correct that because you have only one copy then.
Yeah.
And he says, I feel like file-backed device recreating similar scenarios with a safe ZFS test lab would be fun. Yeah, I think that was one of the first things we added to the ZFS handbook when Benedict and I rewrote it was an example of how to do that.
Yeah, try this out for yourself to see that ZFS actually can repair itself. And yeah, he thanks us for helping us with a little ordeal about ZFS, which taught him a lot. Thanks to Alan, especially, for pointing him in the right direction and lighting the way. And many thanks to the rest of the team, myself, JT, Angela, and Chris for helping to air this and document the process. Yeah, you never know who else is in a similar situation and has tried some of these things before and now has a way of finding the right way of getting out of it.
Yeah, and I'm actually leading a project to make a stronger version of zpool export-F, specifically for the case when you have multiple pools in a system. If one of them gets in a state where it can't move forward, in particular, if it's running off a remote device of some kind, like iSCSI or a virtual device that's backed by online storage, cloud stuff or whatever, if that breaks down and isn't going to come back, you can end up in a situation where, well, you can't export the pool because the disks are offline and I/O is suspended. And ZFS is like, well, I have some data that's waiting to be written, and I don't want to just throw that away. What do you want me to do? And we made a way so that you can actually say, in this case, that device is only, my backup device, right? I'm just ZFS replicating from my main pool to this cloud pool, and I want to just be able to throw it away. And so hopefully that will be finished soon and then can get upstreamed.
Yep. Okay, and last but not least, Patrick, who we know, is having a question about or a comment about Beehive front ends. Goes like this. Hey guys, listening to the last episode, maybe Jake was asking for a more GUI-like front end on Beehive. He did not make it clear though. In that case, he recommends FreeNAS. I use it for all my virtualization servers, and 11.2 update 3 finally looks mature enough to me to be used in production. Yeah, that could be it.
Yep. And then I think CBSD is the other one that has some kind of web GUI.
Yeah, or having some management interface at least to make things more easier to use.
Yeah.
Okay.
It'd be nice someday to have something like Proxmox for BSD, but
some environment that, or just the existing environment can also hook into BSD or Beehive and run those. So it's just another VMM or VM.
Yep.
Okay.
And
before
I just
we close,
wanted to make a small programming note. So soon we will have BSD Now episode 300. So that'll be big. That is just shy of 6 years of doing the show, which is a lot. And I guess it's more than 8 years now of me recording a podcast 1 day a week without ever having missed one. But we will be making changes to BSD Now starting at episode 301. And I think the biggest switch will be that we'll be switching to audio only so that we can deploy a newer, higher quality recording system and more post-production, so editing. So that'll edit out the small gaps to make the episodes shorter and improve the audio quality and try to eliminate more of the crosstalk and any of that kind of stuff. So we're hoping that starting with 301, the quality of the listen of the podcast will be much higher.
Yes, and for the people who are still interested in seeing our faces weekly, the live stream will still be there, and that will have video.
Yep.
All right, that wraps this episode up for this week. See you next time. Thank you.